Last section, we learned about all the different angle pairs that are formed by two lines and a transversal that cuts through that line. We're going to look at very specific lines that the transversal is going to cut through now, and those lines are going to be parallel. Our goal today is to determine what happens when the lines cut by a transversal are parallel. You kind of played around with this a little bit when we did our Desmos activity the last 2 days. So when non-parallel lines are cut by a transversal, we really can't draw any conclusions except for our vertical angles are congruent to one another, because vertical angles are always congruent to one another. And we still have linear pairs that equal 180 degrees. That will never change no matter what type of lines a transversal cuts through. So we're going to be looking at two parallel lines, and we're going to be using this example repeatedly to see if there are any possible conclusions or conjectures that we can make. Remember, we know these lines are parallel because they have these two arrows. So that indicates, if I were to label this A and B, that line A is parallel to line B because we have two arrows that indicate that. So we're going to focus in on alternate interior angles. So there is one pair of alternate interior angles and our second pair of alternate interior angles. So what conjecture can you draw from our two pairs of alternate interior angles? What do you notice about both sets of angles? So if two parallel lines are cut by a transversal, then alternate interior angles are congruent. This isn't just a conjecture based off of one example. This is a proven theorem. So it is true. If these two lines are parallel, alternate interior angles will always be of equal measure. Now we're going to focus in on alternate exterior angles. So there's one set of alternate exterior angles and a second set of alternate exterior angles. The same thing is true. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. Consecutive interior angles. So here's one set of consecutive interior angles and our second set. So we notice right away they are not congruent. Unfortunately, that's the easy one to see. However, both angles equal 180 degrees together. Therefore, they are supplementary. So if two angles are cut by a transversal, then consecutive interior angles are supplementary. Our last angle pair relationship are corresponding angles. So there is one set of corresponding angles, second set, third set, and last set. So same conclusion that we were able to draw for alternate interior and alternate exterior. If two parallel lines are cut by a transversal, then corresponding angles are congruent as well. So how we're going to use this with the application of algebra, or use algebra in order to solve. If we know that two lines are parallel, and that should be marked indicating that we have two parallel lines, if we're given one angle, we can actually identify all other angles. So I'm just going to go in order. I know that angle 2 is 60 degrees because angle 1 and angle 2 together form a linear pair. angle 3 is also 60 degrees. And you could say it's for a variety of reasons. You could use linear pair again, or you could use the fact that 2 and 3 are vertical angles. Angle 4 is 120 degrees. You could say because it's a linear pair with 2, linear pair with 4, or vertical angle with 120. Now here comes our new reasons. Angle 5 is 120 degrees. I know that it's 120 degrees because it is corresponding angles with our original 120. And corresponding angles are congruent. Angle 6 is 60 degrees. It is 60 degrees because it is a linear pair with angle 5. Angle 7 is also 60 degrees. You could say because it's a linear pair with 5. You could say because it's alternate exterior angles with angle 2, vertical angles with angle 6. Multiple reasons why it's 60 degrees. And then lastly, angle 8 is 120 degrees. You could say it's alternate exterior angles with 120, vertical angles with angle 5. You have a lot of choices. So when solving algebraically, the first thing I need to do is recognize, okay, yes, they're parallel. And then what type of angles am I working with? So based off of their location of being in the bottom right-hand corner, I know that these are corresponding angles. And what I know about corresponding angles is that they are congruent to one another. If they are congruent, then that means that this angle measure is equal to this angle measure. So I'm going to take 23x minus 5 and set it equal to 21x plus 5. In example 4, I need to recognize what angles are we working with. These are consecutive interior angles. What do I know about consecutive interior angles? They are supplementary. So if they're supplementary, they equal 180 degrees. So I'm going to add together my two different angles and set them equal to 180. My last set of angles, they have no relationship. They're not corresponding, they're not consecutive interior, they're not alternate exterior. Okay, so therefore I need to do a little bit of work. I have a linear pair, or I can think of angle 1, I guess, since they suggested it, as a linear pair. So that means together, the measure of angle 1 plus 136 is 180. So if I subtract 136 from 180, I find that the measure of angle 1 is 44. Now, these two angles definitely have a relationship. They are alternate exterior angles. So I am working with alternate exterior angles. What do I know about alternate exterior angles? They are congruent. If they are congruent, I'm going to set them equal to one another. And solve. So if I had to sum this up, we either have angles that are congruent to one another or supplementary to one another, and we have to add them up and set them equal to 180 degrees. So our congruent angles are alternate exterior angles, alternate interior angles and corresponding angles. So most of the angles. The one set that is supplementary are our consecutive interior angles.